go ahead and make sure that everything is working as it should. Looks to be good. All right, so we continue. Just sign in here so I can monitor. All right, there, and there. Good, good. All right, so we're set there. We're signed in over here. Nice. All set, ready to go. Okay, so hello everybody. Today is August 21st, 2026, and this is the second or the third part of the stream for today, or the third session today. And what is this? This is an academic stream, so we're just doing studies. We're studying up the kazoo. And what I'm involved with is the review of arithmetic and algebra, hopefully all branches of mathematics by the time we're done, but it is also the opportunity to practice working with Gregg Anniversary Shorthand. So if you are interested in any of that content, it's all down in the descriptions below on YouTube, and I'm sorry, over on Twitch, I was just looking. I don't think, if I'm looking at the description correctly, we don't have any sort of information. So sorry about that. It's probably why it's just virtually zeroville over there on Twitch. But anyway, it's just a matter of getting used to the different software, getting used to streaming, and presenting the information in a clear and coherent manner. So as you see, I have all the links laid out. If you're interested in any of them, then go ahead and take a look. And let's go ahead and get started, shall we? So got this pulled up here. We have, go ahead and close this down over here. And I have Zernal pulled up over here on the right hand side, and I'm currently on article 135. So remember that these are laid out in the articles. Hopefully it's looks like it's moving correctly. Good. All right, so here we go. We had stopped just short on 135. We had stopped just short of completion. Where were we? 7/10, I think we were at the differences. Oh, the deficiency is what we had gotten to. So now let's continue, and the point is placed before the ciphers. Okay. So if anyone ever goes back and watches this content, you just know that it's very boring. It is essentially copywork. So you're watching me do my homework. So you're welcome. And I hope that you are doing something as interesting, hopefully more interesting, with your life. So here we go. Deficiency. And the point is placed before the cipher. Okay, thus 0.7 will be used in future to denote 7/10. Thus denote, let's see what denote is. Just dn will be used to denote, come on, there we go, 7/10. 0.07 for 7/100. and so on. The following tables will give the whole of this notation at one view. Let's see notation. That does not quite look right. Yep. And we'll show its connection with the decimal notation. Explained in the first section. You will observe that the numbers on the right of the units place stand for units divided by 10. One hundred, 1,000, etc. While those on the left are units multiplied by 10, 100, 1,000, etc. The student is recommended always to write the decimal point in a line Let me check recommended. with the top of the figures or in the middle, as it is done here. And never at the bottom, which is really interesting because he's talking about decimal numbers. And of course, the standard now is you only ever write the decimal at the bottom. So I'm not sure exactly what they're talking about, or what De Morgan is talking about. Fascinating. The reason is that it is usual in the higher branches of mathematics to use a point, placed between two numbers or letters which are multiplied together. Thus, 15 times 16, A times B. Okay, interesting. I guess that was the old method for showing multiplication. We've swapped that order now. And for instance, in modern mathematics, we really don't use the dot that much. But if we did, we've actually swapped positions where the dot, if it is above the line of writing, it's used to indicate multiplication. Whereas now, it's like this would be multiplication. And of course, this in Gregg would be multiplication, okay? And if I did the same value with the decimal, it would be this value here, 15.16, and this would be considered a decimal, okay? So not sure exactly what's going on here. Kind of interesting, but we can safely ignore De Morgan's recommendation here because, I mean, obviously we're ignoring it anyway. It's a textbook from 1830, so it's used, yeah, as Barbosa said, it's not rules, it's more guidelines. So with this, we're dealing more with just the English and the copywork. So don't take that particular point, no pun intended, to heart, because in modern mathematics we've simply swapped the order. Okay. So that being said, let me go ahead and continue. Never at the bottom. The reason is that it is usual in the higher branches of mathematics Use a point placed between two numbers. Or letters. Which are multiplied together. Thus 15 dot 6, and that would be multiplication in the old method. A dot B A plus B dot C plus D stand for the products of those numbers or letters. And then, of course, we have this table laid out that lays out for us, which we really can't see. You know, if we crane our head to one side, I'm not going to bother with it. But if we were to take a look at the table, which you're welcome to, PDF is down below, so have at it, be my guest. Hold on. Just need to go over here, check this out. Go. Good. Okay. So, table laid out right here. You could see that it's talking about thousandths as you go up, all the different values, okay? I'm not going to bother with it. So, here are some more examples, okay? In 1,234.5689 inches. The 1 is the inches, the 2 is the 200 inches, the 3 is the 30, so on and so forth, continuing all the way down until you get your fractions of a value, okay? So don't concern yourself with it too much, though. Let's continue on with our next. We're going to do 136, but let me go ahead and read back over 135. Okay. Let's find 136, which is here. Looking for 135, actually. There it is. All right. Let's continue. Highlighter. Decimal fractions are not usually written out or written at full length. It is more convenient to write the numerator only, and to cut off from the numerator, right? And to cut off from the numerator, yep. As many figures as there are in the denominator. When that is possible, but by a point, whenever that is possible, by a point. When there are more ciphers in the denominator than figures in the numerator, as many ciphers are placed before the numerator as supply as will supply the deficiency, and the point is placed before the cipher thus. Thus, dot 7. Yep, and let's go ahead and underline that because that could easily be misunderstood as some sort of Gregg form. Okay? Will be used, thus 0.7 will be used in the future to denote 7 over 10. 0.07, let's go ahead and underline this as well. 0.07 for 7/100ths, and so on. The following table will give the whole of this notation at one view, and will show its connection with the decimal notation explained in the first section. You will observe that the numbers on the right of the units place stand for units divided by 10, 100, 1000, etc. While it is on the left are units multiplied by 10, 100, 1000, etc. The student is recommended always to write the decimal point, and this was where we had to kind of deviate from Augustus De Morgan because we don't write that way anymore, but oint, right? Let me check point quickly. Yep, there's point. And let's make it just a little bit more rounded. There we go. The decimal point in a line with the top of the figures, or in the middle as it is done here, and never at the bottom. The reason is that it is usual in the higher branches of mathematics to undo, redo, there we go, to use a point placed between two numbers or letters which are multiplied together. Thus 15 times 16, A times B, and then the sum of two values, A plus B times C plus D, stand for the products of those numbers or letters. Okay, like I said, we've moved away from that, so it's usual it's usual to not do that particular process. Okay? Grab a little drink of water and then we continue. Okay, scoot this down the page a little bit, and we continue past the table. Like I said, table is worth looking at, just not for right now. So here we go at 136, not 135, 136. The ciphers on the right hand of the decimal point serve the same purpose as the ciphers in Article 10. The ciphers on the right hand of the decimal point they are not counted as anything themselves. But serve to show the place in which the accompanying numbers stand. They might be dispensed with by writing the numbers in ruled columns. as in the first section. They are distinguished from the numbers which accompany them by calling the latter significant figures. Thus, 0.003747 is a decimal of 7 places with 4 significant figures. Etc. That concludes 136. Let's go back and read it. In context. Always very good when you're doing writing. The ciphers on the right hands of the decimal point several serve. What was that serve? That cassette is serve and several. I just noticed I might have done that incorrectly. No, they are the same. Several, and let me check serve. Same form. Same form. Point serve the same purpose as the ciphers in Article 10. They are not counted as anything themselves, but serve to show the place in which the accompanying numbers stand. They might be dispensed with by writing the numbers in ruled columns, as in the first example, as the first section. They are distinguished from the numbers which accompany them by calling the latter significant figures. Thus, 0.0003747 is a decimal of 3 places with 3 significant figures, etc. Article 137. The value of a decimal is not altered by putting any number of ciphers on its right. Take, for example, 0.3 and 0.300. The first, according to Article 135, is 3 over 10, and the second is 300 over 1000. Which is made from the first by multiplying both its numerator and denominator by 100. And according to Article 108, is the same quantity. Thus concludes 137. I'm not going to read that back because that is a relatively short paragraph, and so I'm going to skip forward. Let's do 138. To reduce two decimals to a common denominator, put as many ciphers on the right of that which has the smaller number of places. In both fractions the same. No, as will make the number of places in both fractions the same. Take, for example, 0.54. And 4.3297. The first is 54 over 100. And the second $43,297. $10,000 over 10,000. Multiply the numerator and denominator of the first by 100. According to Article 108, which reduces it to 5,400 over 10,000. Which has the same denominator. As 4,329 or 43,297. over 10,000. But 5,400 over 10 thousandths is 0.5400. According to Article 135. In whole numbers, the decimal point should be placed at the end. Thus, 129 should be written 129 point, or the decimal point. It is, however, usual to omit the point. But you must recollect that 129 and 129.000 are of the same value. Since the first is 129, and the second 129 with 129,000 1,000ths. And that's the end of Article 138. Let's go ahead and read back over it. To reduce two decimals to a common denominator, put as many ciphers on the right of that which has the smaller number of places as will make the number of places in both fractions the same. Take, for example, 0.54 and 4.3297. The first is 54 hundredths, and the second 43,297 ten-thousandths. Multiply the numerator and denominator of the first by 100 according to Article 108, which reduces it to 5,400 or 5,400 ten-thousandths, which has the same denominator as 43,297 over 10,000. But 5,400 ten-thousandths is 0.5400 according to Article 135. In whole numbers, the decimal point should be placed at the end. Thus, 129 should be written 129 with a point. It is, however, usual to omit the point, but you must recollect that 129 and 129.000 are of the same value, since the first is 129 and the second 129,000 over 1,000ths. Article 139. The rules which were given in the last chapter for addition. Subtraction, multiplication, and division apply to all fractions. And therefore to decimal fractions among the rest. But the way of writing decimal fractions, which is explained in this chapter, let's go ahead and add a page below. Which is explained. So let's see, decimal fractions, which is explained. Makes the application of these rules more simple. We proceed to the different cases. All right. Suppose it required to add 42.634 45.286 2806 2.0010 and 54 0.00040 zeros. These are decimal fractions whose numerators $426,340 452,806. Interesting. 2010 or 20,010. And 540,000. And whose common denominator is 10,000. By Article 112, their sum is that monstrosity. I'm not going to write it out. Their sum is see textbook. Which is the result one, 4, 3, 9, 1, 5, 6 over 10,000. Or 1, 4, 3 point 9, 1, 5, 6. The simplest way of doing this is as follows. Write the decimals down under one another. So that the decimal points may fall under one another. Thus. And that thing right there, once again, I'm not going to write it. Put that in the textbook, because I don't need to know how to write numbers. I already know. See textbook. There we go. Add the different columns together as in common addition. And place the decimal point under the other decimal points. See textbook for examples. Moving on to Article 140, but before I do that, let me read through Article 139. Okay. There's Article 139. Nope, that's 129. Article 139. That's 138. 138 was relatively short, wasn't it? So 139 should be right around here. It was after that big old value of 129,000 something. Looking. There it is. Let's begin. Article 139. The rules which were given in the last chapter are for addition, subtraction, multiplication, and division apply to all fractions, and therefore to decimal fractions among the rest. But the way of writing decimal fractions, which is explained in this chapter, makes the application of these rules more simple. We proceed to the difference, or to the different cases. Suppose it required to add 42.3639, 45.2806, 2.0010, and 54.0000, 4 zeros. These are decimal fractions whose numerators are these values here. I'm not going to read them out. You guys can see them. And all these. And whose common denominator is 10,000, 10,000s. But by Article 112 is, and then their sum is, right? Where's their sum? By Article 112, what am I missing? By Article 112, their sum is, I forgot their sum, so let me go ahead and move this over. There we go. Their sum is and then see textbook. 42, if we take a look at that value right here, it's that long string, okay? It's that long string of values all over 10,000, and so see textbook, which is 143 or 1,439,159 or 10,000ths or 143.9156. The simplest way, let me go ahead and check simplest way. Not way, simplest. Oh, that's right. Simplest requires the ST ending. Okay. The simplest way of doing this is as follows. Write the decimal down over the, no, under, that's under one another. Write the decimals down under one another, so that the decimal points may fall under one another. Thus, and then see the textbook here. Line up the decimal points. See textbook. Add the different columns as in common addition, and place the decimal point under the other decimal points. Once again, see textbook for examples. Okay, and then there are the examples there below. Skip past that, go straight to 140. Once again, we're not going to write all this out. Suppose it required to subtract. Suppose it required to subtract 91.07324 from 137.321. These fractions, when reduced to a common denominator, is 91.07324, or R. And 137.32100 according to Article 138. Their difference is, therefore, check textbook or see textbook, that value, which is I'm going to skip the fraction. You go straight to the value 42,000, no, just 42.24776. This may be most simply done as follows. Write the less number under the greater. So that its decimal point may fall under that of the greater. Thus, and once again, consult textbook. Subtract the lower from the upper line. And wherever there is a figure in one line, and not in the other, proceed as if there were a cipher in the vacant place. All right. Moving on. So once again, there are exercises there. I'm just going to make note of it and move on. Exercises in textbook. Okay. Go back and read over 140. Suppose it required to subtract 91.07324 from 137.321. These fractions, when reduced to a common denominator, are 91.07324, and 137.13213210, according to our Article 138. Their difference is, therefore, see the textbook, okay? Their difference, therefore, is that value, see the textbook, which is 42.24776. This may be most simply done as follows. Write the less number, or write the least number, lesser, should be lesser, right? Write the less number under the greater so that its decimal point may fall under that of the greater. Thus, consider textbook, okay? Consult textbook. Subtract the lower from the upper line, and wherever there is a figure which one line in one line and not in the other, proceed as if there were a cipher in the vacant place. Once again, exercises in textbook. Exercises in textbook. Okay. All right, moving on. Article 141. The multiplication of a decimal by tens, 100, 1000. The multiplication of a decimal by 10, 100, 1000, etc. is performed by moving by merely moving the decimal to the right. Suppose, for example, $13.2079. Let's add another line below. Page 11. Suppose, for example, 13.2079 2079 is to be multiplied by 100. The decimal is whatever that number is, okay? It's that number, so let's just say the decimal is value. I'm just going to say value. All right? Which is multiplied by 100. According to Article 117. Is, once again, value. Okay? Don't need to write it out. It's 117, which is going to be 1,000. That's 132,079 over 100, comma, or and here I will write this out because it's more manageable, easier to read, or 132, 1,320, yeah, 1,320.79. Again, 1.309. Sheesh. Okay, and then the rest of the example again, and then I'm just going to say consult textbook. Once again, don't need to waste my time or the stream's time. Not that there's anyone here, but I don't need to waste anyone's time by simply writing out numbers, okay? So we're going to skip past that. From these and other instances, we get the following rule, okay? So we're going to skip forward. From these and other instances, in instances requires 2 S's, I believe. Yep, so that's instance. So instances would require the double. Other instances, from this and other instances, we get the following rule. To multiply a decimal fraction by a decimal fraction, according to Article 126, move the decimal point as many places to the right as there are ciphers in the decimal number. When this cannot be done, annex ciphers to the right of the decimal. According to Article 137, until it can. All right, that's all of 141. Let's go ahead and read over it. And that was the following, the multiplication of a decimal. So let's just do this as 141. Okay, the multiplication of a decimal by 10, 100, 1000, etc. is performed by by merely moving the decimal to the right. Suppose, for example, 13.2076 is to be multiplied by 100. The decimal is, and then that value, right, which is, so the decimal is whatever that value is, which is multiplied by 100 according to Article 17. So you take a look at the value there at 117, or 1320.79. Again, and then we take a look at the rest of the remainder, consult the textbook where that value is listed right there, and we end up with 1,000 once we multiply it by 100. Again, if we wanted to multiply it by, what's that value? 100,000, then we would get that monstrosity. Okay, so we're going to skip past all that, and we're going to go over and go ahead and do the reading, because that's the important part. From these and other instances, we get the following rule. To multiply the decimal fraction by a decimal fraction, according to Article 126, move the decimal point that many places to the right as there are ciphers in the decimal number. When this cannot be done, annex ciphers to the right of the, let's change that to a right, to the right of the decimal according to Article 137 until it can. All right, moving on, 142. And as before, if it's a value that is greater than, I'm going to say 4 digits, if the number requires more than 4 digits, I just write value, okay? So we can then take a look at the textbook to consult, because right now, like I said, copywork is important, not numbers. All right, so here we go. Moving on, 142. Suppose it required to multiply. Suppose it required to multiply 17.036 by 4.27. Okay, and once again, I'm also not going to really pay attention to his point about the middle, because we know that the rules have changed and we now have the decimal point written at the base. All right, moving on. The first of these decimals is, here we go, the first of these decimals is value. Okay, and the second also value. Ignore the actual, or you can take a look at the textbook. All right, by Article 18, 118, the product of these fractions has for its numerator the product. The product of these fractions has for its numerator the product of set 17036 and 427. And for its denominator, the product of 1,000 and 100. And for its denominator, the product of 1,000 and 100. Therefore, this product is value or 72.74372. This may be done more shortly, like everything else. This may be done more shortly. Let's see what shortly is. Oh, there we go. This may be done more shortly by multiplying the two numbers. One 7036 and 427 and cutting off the decimal point as many places. And cutting off the decimal point as many places as there are decimal places, both as there are decimal places in 17.036 and 4.27. Because the product of two decimal numbers will contain product as many ciphers as there are ciphers in both. Okay, let's go ahead and read over 142. Drop another paragraph marker. And 142. There it is. Oh wait, did I do? Yeah, well, yeah, okay. Here we go. Suppose it required to multiply 17.036 by 4.27. The first of these decimals is the value, and the second is also a value. By 118, the product of these fractions has for its numerator the product of 107 of what is that value? 17,036 and 427. And for its denominator, the product of 1,000 and 100. Therefore, this product is the value, or 72.74372. This may be done more shortly by multiplying the two numbers 17,036 and 427. And cutting off. Is it cutting off? Yeah, I forgot the dot. Okay. And cutting off the decimal point as many places as there are decimals as there are decimal places in 17.036 and 4.27, because the product of two decimal numbers will contain as many ciphers as there are ciphers in both. All right, that's it. Article 143. Okay. 143. This new question now arises. Arises double R colon. What if there should not be as many figures in the product? If there should not be as many figures in the product as there are decimal places in the multiplier and multiplicand. What was multiplicand? There it is. Okay. The multiplicands together. To see what must be done, in this case, multiply point 172 by 0.101 or or value and or by value. Once again, I don't need to copy those fractions. Okay, the product of these two is value. For 0.017372 according to Article 135. It is interesting how he references everything. It's just like citations in a paper. I wonder if maybe that's where the modern understanding of citations, of citing your sources, if it stems from the writings of guys like this. Okay, therefore, when the number of places in the product, therefore, when the number of places in the product is not sufficient and sufficient to does that allow? Yep. Is not sufficient to allow the rule of the last article to be followed as many ciphers must be placed. How many more lines? 143, 144, 145, 146. Yeah, still lots of content left. 148. Whoosh. Whoosh. That's a lot. All right, I'm going to be busy here for a while. Lots of work on decimals. That's crazy. Okay. Okay. Grab a little bit of water, then we carry on. Okay. As many let's go back. Which article were we on? Article 143, right? There it is. As many, therefore, when the is sufficient to allow the rule of the last article to be followed, as many ciphers must be placed, as many, oh, we're going to add another page. So I'm going to go to 12 pages on this, and then we'll add another, or a second half of the document, okay? So we're going to go to Elements of Arithmetic. Section 6, page 12. Okay. As many what is this? As many ciphers followed, comma, as many ciphers must be placed at the beginning as will make up the deficiency. No, it goes deficiency, like so. Let's check that. There it is. There it is. Good, good. All right. So we placed in the deficiency period. Let's go ahead and read back over that. Article 143. This new question now arises. What if there should not be as many figures in the product as there are decimal places in the multiplier and multiplicand together? To see what must be done in this case, multiply 0.172 by 0.001, or the value, right, the fractional value by the fractional value. And the product of these two is the fractional value, okay, or 0.017372, according to Article 135. Therefore, when the number of places in the product is not sufficient to allow the rule of the last article to be followed, as many ciphers must be placed at the beginning as will make up the deficiency. All right, and then we have additional examples, so I'm going to make a note of that. So we'll say exercises or examples to be more precise. Examples in textbook. Examples in textbook. Okay. Skip all that. Go on to 104 or 144. The division of a decimal by a decimal number such as 10, 100, 1000, etc. such as, right? Such as, so let's do that here. This is such as. 10, 100, 1000, etc. is performed by moving the decimal point as many places to the left. Is performed by moving the decimal point as many places to the left as there are ciphers in the decimal number. If there are not places, if there are not places enough in the dividend to allow of this annex ciphers to the beginning. Wait, did I jump? No. No, I don't think I jumped. No, we just did 143, right? Yeah, because we did multiplication. This is division. Okay. Annex ciphers to the beginning of it, to the beginning of it until there are. For example, divide 1734.229 by 1000. The decimal fraction is the value. The decimal fraction is value, comma, which divided by 1000 according to Article 123 is value, or the decimal version, which is 1734229. Okay? If in the same way, 1.2106 be divided by 10,000, the result is 0.0001210, and 6. All right, that's the end of that article, and we're done. We're done for today. So that was another 7 hours. Very nice. Thank you very much to anyone who jumped in or anyone who saw this. I appreciate you. I appreciate you so much. And I hope that you were able to accomplish everything that you intended to accomplish today. And hope that your evening goes smoothly. And I will see you tomorrow. I'm not sure if I'll be able to do 7 hours tomorrow. I have a couple other obligations. But I will definitely try. And anyway, so take care, and I will see you later. Bye-bye.